Well, hi there, boys and girls. Today we're going to take a look at how to take a Taylor polynomial and condense it down and write it as a Taylor series. So we're going to compact it down to get a general term, a formula, if you will, to generate all of the terms in the polynomials. We're going to compact it down to a series. So we're going to practice that. So off we go. So we want to find a Taylor series for f of x equals e to the 5x centered at 2. Give the first 4 non-zero terms. That means we cannot have any of the terms equal 0. And we're not going to go to a certain degree here. We're just going to count 4 terms. And then we want the general term. The general term is going to be right here, which is the same thing as this. There's your general term, and we're going to put it in a series form. So let's write down what we need. First of all, we need to know the function we're dealing with is e to the 5x, and we're going to need some derivatives. So f prime is going to equal 5e to the 5x because of the chain rule. F double prime is going to equal, we're going to get another factor of 5, so we actually have a 5 squared. I'm going to call that 25e to the 5x. And then f triple prime is going to equal another factor of 5 is going to be 125e to the 5x. Now this is going to be 4 pieces of information, and if none of these are 0, then that will be my first 4 terms. So we need to plug in our 2. F of 2 is going to equal e to the 10th. F prime of 2 is going to equal 5e to the 10th. F double prime is going to equal, that is 2 tick marks there, yes. F double prime is going to equal 25e to the 10th. And F triple prime is going to equal 125e to the 10th. So we're going to throw it in our formula. We now have our function value and the first 3 derivatives values. None of them were 0, so we're just going to toss it into the formula. So we're going to write this down as e to the 10th. There's f of 2, f of our center, plus f prime of 2, 5e to the 10th, times x minus 2. And then plus 25e to the 10th over 2 factorial times x minus 2 squared, and then plus 125e to the 10th over 3 factorial times x minus 2 cubed. Now let's see if we can condense this down to a general term. So I'm going to have a sigma. The last thing I'm going to do is deal with whether I'm going to start at 0 or 1. Now what do we have in common here? We've got a constant for sure. We've got an e to the 10th. We also have powers of 5. We also have powers of x minus 2. So I'm going to show you the constant here as e to the 10th, and then my powers of 5 we're going to write as 5 to the n, and my powers of x minus 2 is x minus 2 to the n, and then on the denominators we have n factorial. Now to generate the first term of e to the 10th with no powers of x minus 2, I'm going to start my n at 0. If you plug in, then we're just going to check and make sure that we did this right. If we plug in 0 for n, 5 to the 0 is 1, x minus 2 to the 0 is 1, 0 factorial is 1, and I just have this e to the 10th, and there it is. And if I plug in a 1, I'll have 5 to the 1st, e to the 10th, x minus 2 over 1, and there it is. So this is your power series, and this is going to equal, we're going to say from now, e to the 5x. Now yesterday we did an interval convergence, and so I would need to say it equals or converges to e to the 5x. Does it converge for all real numbers? Is it a certain interval? Is it certain, does it only converge at the center? That was yesterday, but for now we've written the Taylor series. There are 3 special ones that we have to know, and we've developed these in class. And so we've got an e to the x series, and we've already known that e to the x from homework is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. I think we did them like 2 days in a row. One day we went to the 3rd degree, one day we went to the 4th degree, plus dot dot dot. Now we're going to write it as a series. So there's e to the x. So e to the x is going to equal a summation, a series. N equals, I'll reserve this as a 0 or 1 to figure out what I have here. I've got increasing powers of x, so I can write that as x to the n. I'm not going to put the constant 1 in front of that, over n factorial. And I'm going to start this at 0. And so if I plug in 0, for n I get x to the 0, which is 1, over 0 factorial is 1. And if I plug in 1, I get x to the first over 1. And if I plug in 2, I get x squared over 2 factorial for this, so this works. And now, from last night's homework, you know that the interval of convergence of e to the x is all real numbers. So this formula, this power series, will equal e to the x for all values of x. That went in our homework as well. And we generated a Taylor polynomial for sine, and we got x minus x cubed over 3 factorial. We skipped the x squared because that derivative involved a 0. When we plugged in our 0, we canceled the entire term. And then we have plus x to the 5th over 5 factorial. We also noticed that the x to the 4th disappeared because the derivative involved a sign, and when we plugged in 0, we got 0, so the x to the 4th is gone. So what we want to do is we want to write this as a power series. This one is a little trickier. Sine of x is going to equal, it's a summation, n equals, I'll reserve this for now, something to infinity. There's a couple different ways to write this one, but it's alternating, so it needs to have a power of -1. And I'll just put an n there for now. We're going to make sure it works to make sure the first term is positive. And I have odd powers of x. Odd powers, the way you generate a series of odd powers or odd numbers is 2n plus 1. An even number plus 1 will be an odd number. And then we divide this by, there's factorials on the bottom, 2n plus 1 factorial. Now let's just see, if we plug in 0, we're going to get -1 to the 0, which is 1. X to the 2 times 0 plus 1 is 1, x to the first, over 2 times 0 plus 1 is 1, I'll have a positive x to the first over 1, and that's what I want. And if I plug in a 1, I'll get a negative x cubed over 3 factorial. So I need to start this at 0. And from last night's homework, or yesterday's homework, number 6, we know that the interval of convergence is -infinity to infinity. This series will converge to sine of x for all values of x. You can plug any x you want in here, and it will converge to that value of sine. Alright, so now for cosine. The third one we have to know. We have developed cosine, and we know that cosine from homework worked out to be 1 minus x squared over 2 factorial. We skipped the x term because the derivative was a negative sign, and when we plugged in 0, it got 0, and we canceled it. And the next term was plus x to the 4th over 4 factorial, and we got this little pattern here. So this is a series, well, summation, n equals, and this one I'll just tell you is going to be n equals 0 to infinity. It's alternating, so -1 to the n. This is a little easier to write because we just have even powers of x. So that's going to be x to the 2n over 2n factorial. And this is valid for all real numbers. The radius of convergence was infinity. The interval of convergence, -infinity to infinity. This power series will converge to cosine of x for any value of x that you want. Now, if you memorize these three, you are going to save yourself a lot of time. And there's going to be some questions I honestly don't think you're going to have time to answer if you just find derivatives and then try and plug them into the Taylor polynomial formula. If you memorize these, we can manipulate these known series to develop new series, and I'm going to show you how to do that. We can substitute in, we can multiply or divide, we can add or subtract, and later on we're going to differentiate or integrate. So let me show you how this works. We want to develop a Maclaurin series for f of x equals sine of x squared. Find the first 4 non-zero terms and the general term. Well, I know from memory, and hopefully you will soon, that sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. There's the first 4 non-zero terms for sine. And then we have, of course, the power series is n equals 0 to infinity of x to the 2n plus 1. I need to put my alternating in there. I guess I'll put it out here to the right. That's not the best, but I'll put it there. And then over 2n plus 1 factorial. If you memorize this, then you can find a Maclaurin series for sine of x squared. All you're going to do is we're going to substitute x squared everywhere we see an x. So that's going to be x squared. We replace that x with x squared minus x squared cubed over 3 factorial plus x squared to the 5th over 5 factorial minus x squared to the 7th over 7 factorial plus dot dot dot, and even into the series. We're going to replace that x with an x squared. So I'm going to have from 0 to infinity. I'll put my alternating part first. And I'm going to have x squared to the 2n plus 1 over 2n plus 1 factorial. Now let's clean this up a little bit. So sine of x squared is going to equal x squared minus x squared cubed. You remember, you multiply those powers, so that's x to the 6th over 3 factorial plus, and then x to the 10th over 5 factorial. That's a 10, I promise you. And then minus x to the 14th over 7 factorial plus dot dot dot, summation from 0 to infinity of negative 1 to the n. Now if we multiply these powers, 2 times 2n plus 1 is 4n plus 2. So that's going to be x to the 4n plus 2 power over 2n plus 1 factorial. So if you memorize their series for sine, you can develop sine of blah by just substituting it blah in for x. Now what about if I have a polynomial times cosine x? Well, I know that what cosine x is. Cosine x is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot 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 negative 1 to the n x to the 2n over 2n factorial. That's the general term, and it's a general term even without the sigma in front of it. So you don't have to commit yourself to a sigma. You can just still write the general term without the sigma. Now if I want to say the function equals something, I would need to commit myself to a sigma. So there's my general term. X cosine x is going to mean multiply x through what cosine equals. So we're just going to take all of this and multiply it through by an x. So that's going to be just distributed, hippity hoppity. I'm going to get x minus, because x times 1 is x times x squared is x cubed over 2 factorial plus x to the 5th over 4 factorial minus x to the 7th over 6 factorial. So there's 1, 2, 3, 4 terms. Then for my general term, if I multiply x times x to the 2n, you add the degree of 1 to the degree of 2n, you get x to the 2n plus 1 power over 2n factorial. Alright, so let's take a look at one last example. We want to add two series together and then even divide by 2. So let's see if we can do this. Let's write the term for e to the x and e to the negative x. E to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 dot. And I'm going to show you that I'm going to need a few more. I realize that's 4 terms and I should stop there, but I've done this problem so I know what happens. X to the 4th over 4 factorial plus x to the 5th over 5 factorial plus x to the 6th over 6 factorial. Now what about e to the negative x? I can generate this by replacing all of those x's with negative x. So 1 minus x. If you replace x with a negative x but then square it, it still stays positive. Plus x squared over 2 factorial, and then minus x cubed over 3 factorial, and then plus x to the 4th over 4 factorial, and then minus x to the 5th over 5 factorial, and then plus x to the 6th over 6 factorial. Now let's add these together, term by term, e to the x plus e to the negative x. So let's see what happens. 1 plus 1, well that's easy, that's 2. What happens when we add the x to the first and the negative x to the first? Those are going to cancel, so that term's gone. Then if I add the next term together, x squared over 2 factorial plus x squared over 2 factorial, I'm going to have 2 of them. 2x squared over 2 factorial. And then what happens here? Those cancel. And I get plus 2x to the 4th over 4 factorial. My x to the 5th cancel, and my x to the 6th, I get 2 of those. So that's why I had to go a few more terms, because every odd power of x is going to end up canceling each other. So finally, I'm going to write out what my answer is here. E to the x plus e to the negative x over 2 is going to equal, I'm going to divide everything by 2. So term by term, 2 divided by 2 is 1. 2x squared over 2 factorial divided by 2 just gives me x squared over 2 factorial, and then plus x to the 4th over 4 factorial, and then plus x to the 6th over 6 factorial. And let's see if we can write our general term here. Plus dot 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 summation. Is it alternating? No. So I'm not going to write down a -1 to a power. What do I have up here in the numerator? I've got x to even power, so that's x to the 2n. On the denominator, I've got even factorial, so that's 2n factorial. And I'll need to start this at 0 so that my first term can be a 1. Alright, so that's it for Taylor series for the first day, and I'll see you guys tomorrow.